When working with electrical installations, particularly in outdoor environments, it's crucial to understand how ambient temperature affects the ampacity of conductors. The National Electrical Code, or NEC, provides tables and correction factors to ensure electrical systems operate safely and efficiently. Table 310.16 is a key resource for determining the allowable ampacities of insulated conductors rated up to 600 volts, and it includes correction factors for ambient temperatures other than 30 degrees Celsius, which is 86 degrees Fahrenheit. These correction factors are multipliers applied to the base ampacity of a conductor to adjust for the actual ambient temperature where the conductor is installed. If the ambient temperature is lower than 30 degrees Celsius, the conductor can carry more current than its listed ampacity because it can dissipate heat more effectively. Conversely, if the ambient temperature is higher than 30 degrees Celsius, the conductor's ampacity must be reduced to prevent overheating and potential insulation damage. In the specific case of an outdoor motor control application located in an area where the ambient temperature never exceeds 50 degrees Fahrenheit, which is approximately 10 degrees Celsius, you can indeed take advantage of the correction factor provided in Table 310.16. For ambient temperatures of 50 degrees Fahrenheit or less, the correction factor is 1.5. This means you can multiply the ampacity of a 75 degrees Celsius rated conductor by 1.5 to determine the adjusted ampacity suitable for that environment. Here's how the calculation works. First, identify the base ampacity of the conductor from Table 310.16 based on its size and insulation type. Secondly, locate the correction factor corresponding to the ambient temperature in Table 310.16. In this case, it's 1.5 for temperatures of 50 degrees Fahrenheit or less. Thirdly, multiply the base ampacity by the correction factor to obtain the corrected ampacity. For example, let's say you're using a 75 degrees Celsius conductor that has a base ampacity of 50 amps, according to Table 310.16. To determine the corrected ampacity for an ambient temperature of 50 degrees Fahrenheit or less, you would perform the following calculation. Corrected ampacity equals 50 amps multiplied by 1.5, which equals 52.5 amps. This means that in this specific application, the 75 degrees Celsius conductor can safely carry 52.5 amps without exceeding its temperature rating. It's important to note that several factors must be considered when applying these correction factors. Firstly, the conductor must be properly sized to handle the calculated load. Secondly, all applicable overcurrent protection devices, such as circuit breakers or fuses, must be sized appropriately to protect the conductor at its corrected ampacity. Thirdly, the terminations and equipment connected to the conductor must be rated for the conductor's temperature rating. For example, if you are using a 75 degrees Celsius conductor, the terminations and equipment must also be rated for 75 degrees Celsius. Fourthly, always consult the latest edition of the NEC and any local electrical codes for specific requirements and restrictions in your area. These codes may have additional rules or amendments that affect the application of ampacity correction factors. Fifthly, consider any derating factors that may apply due to the number of current carrying conductors in a raceway or cable. Table 310.15. 8.3. Provides adjustment factors for situations where multiple current carrying conductors are bundled together. These adjustment factors reduce the allowable ampacity of the conductors to prevent overheating. The NEC defines a current carrying conductor as a conductor that carries current under normal operating conditions. Neutral conductors in certain 3-wire circuits and grounding conductors are generally not considered current carrying conductors for the purpose of applying these adjustment factors. Sixthly, when making ampacity calculations, always use the most conservative values to ensure safety and compliance. If there is any doubt about the correct ampacity or application of correction factors, consult with a qualified electrical engineer or inspector. Seventhly, document all ampacity calculations and correction factors used in the design and installation of the electrical system. This documentation is essential for future reference and for demonstrating compliance with electrical codes and standards. Let's delve a little deeper into the NEC requirements related to conductor ampacity and temperature ratings. Section 110.14 C of the NEC addresses the temperature limitations of conductors. This section specifies that conductors with higher temperature ratings can be used, provided that the terminations and connected equipment are also rated for the same temperature. However, the allowable ampacity of the conductor is still limited by the lowest temperature rating of any connected termination, conductor, or device. For example, if you are using a 90 degrees Celsius conductor but connecting it to a termination rated for only 75 degrees Celsius, you must use the 75 degrees Celsius ampacity rating for the conductor. This is to ensure that the termination does not overheat and cause a fire hazard. Furthermore, Section 310.15 of the NEC provides detailed information on determining conductor ampacity. This section covers various factors that can affect ampacity, including ambient temperature, conductor insulation type, and the number of current carrying conductors in a raceway or cable. It's important to carefully review Section 310.15 and all related tables and notes to ensure that you are properly determining conductor ampacity for your specific application. In addition to Table 310.16, the NEC also includes other tables and information that may be relevant to ampacity calculations. For example, Table 310.17 provides ampacities for conductors installed in free air. Table 310.20 specifies ampacities for service entrance conductors. Annex B of the NEC contains examples of ampacity calculations for various types of installations. These examples can be helpful in understanding how to apply the NEC requirements to real-world situations. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It's essential to use the latest edition of the NEC to ensure that your electrical installations comply with the most current safety standards. Many jurisdictions also adopt local electrical codes that may have additional requirements or amendments to the NEC. It's important to be familiar with the electrical codes in your area and to comply with all applicable requirements. When working with electrical systems, safety should always be the top priority. Always de-energize circuits before working on them and use appropriate personal protective equipment such as gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Improperly installed electrical systems can be dangerous and can cause fires, electric shock, and other hazards. Understanding and applying ampacity correction factors is an important aspect of electrical safety. By properly adjusting conductor ampacity for ambient temperature and other factors, you can ensure that electrical systems operate safely and reliably. Remember to always consult the NEC and local electrical codes, and to seek the advice of a qualified electrical professional if you have any questions or concerns. In the specific scenario described, the use of a 75 degrees Celsius conductor with a corrected ampacity of 52.5 amps in an outdoor motor control application with ambient temperatures never exceeding 50 degrees Fahrenheit is acceptable, provided that all other NEC requirements are met, including proper overcurrent protection, suitable terminations, and compliance with all applicable codes and standards. The correction factor of 1.5 allows for a slightly higher current carrying capacity due to the cooler ambient temperature, which enhances the conductor's ability to dissipate heat. This adjustment ensures that the conductor operates within its safe temperature limits, preventing potential damage or failure. It's also worth mentioning that selecting the appropriate conductor size and insulation type is crucial for the overall performance and longevity of the electrical system. Factors such as voltage drop, conductor resistance, and environmental conditions should be carefully considered when making these selections. Voltage drop can cause equipment to operate inefficiently or even fail. Conductor resistance can lead to energy losses and heat generation. Environmental conditions such as moisture, corrosion, and exposure to sunlight can degrade conductor insulation and reduce its lifespan. By taking these factors into account and selecting the right conductors and components, you can ensure that the electrical system operates safely, efficiently, and reliably for many years to come. In summary, when dealing with ampacity correction factors, remember these key points. Firstly, consult Table 310.16 of the National Electrical Code for the appropriate correction factors based on ambient temperature. Secondly, multiply the base ampacity of the conductor by the correction factor to determine the adjusted ampacity. Thirdly, ensure that all other NEC requirements are met, including proper overcurrent protection, suitable terminations, and compliance with all applicable codes and standards. Fourthly, consider any deterring factors that may apply due to the number of current carrying conductors in a raceway or cable. Fifthly, always use the most conservative values when making ampacity calculations to ensure safety and compliance. Sixthly, document all ampacity calculations and correction factors used in the design and installation of the electrical system. Seventhly, if you have any questions or concerns, consult with a qualified electrical engineer or inspector. By following these guidelines, you can ensure that your electrical installations are safe, efficient, and compliant with all applicable codes and standards. Remember that electrical work can be dangerous, and it's always best to seek the help of a qualified professional if you are not comfortable performing the work yourself. Staying informed and adhering to best practices are crucial for maintaining electrical safety and preventing potential hazards. Also, be aware that specific local regulations might impose stricter requirements than the NEC. Always check with your local authorities to ensure full compliance. This proactive approach to electrical safety not only protects people and property, but also contributes to the overall reliability and performance of electrical systems. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrical engineer or inspector before making any decisions about electrical installations or modifications. The NEC is a complex and comprehensive document, and it's essential to have a thorough understanding of its requirements to ensure safety and compliance. Keep in mind that the electrical codes and standards are constantly evolving, so it's important to stay up to date on the latest changes and best practices. Participating in continuing education courses and professional development activities can help you stay informed and maintain your expertise in the field of electrical engineering. By continuously learning and improving your skills, you can ensure that you are providing the best possible service to your clients and contributing to a safer and more reliable electrical infrastructure. It is crucial to have the latest version of the NEC, as electrical codes are updated regularly to reflect new technologies, safety practices, and industry standards. These updates often include revisions to ampacity tables, correction factors, and other critical information that directly impacts the design and installation of electrical systems. Using outdated codes can lead to non-compliance and potentially hazardous conditions. In addition to staying current with the NEC, it is also important to be aware of any local amendments or regulations that may apply in your specific jurisdiction. Local authorities often adopt and modify the NEC to address unique regional concerns or to incorporate specific requirements that are not covered in the national code. These local amendments can vary significantly from one area to another, so it is essential to check with your local building department or electrical inspector to ensure that you are complying with all applicable requirements. Moreover, comprehensive documentation is essential when performing electrical work, especially when applying ampacity correction factors. This documentation should include detailed calculations, conductor specifications, ambient temperature readings, and any other relevant information that supports your design decisions. Proper documentation serves as a valuable record of your work and can be used to demonstrate compliance with electrical codes and standards. It can also be helpful for troubleshooting or making future modifications to the electrical system. When documenting your work, be sure to use clear and concise language and to organize the information in a logical and easy to understand manner. This will make it easier for others to review and understand your design decisions. Furthermore, regular inspections and maintenance are crucial for ensuring the ongoing safety and reliability of electrical systems. Inspections can help identify potential problems or hazards before they become serious, while maintenance can help prevent equipment failures and extend the lifespan of the system. It is recommended to schedule periodic inspections by a qualified electrical inspector to assess the condition of the electrical system and to identify any areas that require attention. Maintenance activities may include cleaning electrical panels, tightening connections, and replacing worn or damaged components. By performing regular inspections and maintenance, you can help prevent electrical fires, equipment failures, and other hazards. In addition to these practical considerations, it is also important to cultivate a strong safety culture in the workplace. This involves promoting awareness of electrical hazards, providing adequate training to employees, and enforcing strict safety protocols. A strong safety culture can help prevent accidents and injuries and create a safer working environment for everyone. It is also important to encourage employees to report any potential safety concerns or hazards they may encounter. By creating a culture of open communication and collaboration, you can ensure that safety remains a top priority. Remember, electrical safety is everyone's responsibility, and it requires a commitment from all stakeholders to uphold the highest standards of care.